Hello, everybody. We are the team Big Data Warrior 9, and our team members are Ian, Angela, Isaac, myself, Annie, and Darian. So let's get into the problem statement. So we are uh, uh, we are working on the weather patterns and warnings with the live historical data. So our source is weatherapi.com, and we have used GCP to collect, transform, analyze, and present weather data for 9 American cities to demonstrate how we might predict weather patterns and events. So this is for like the day-to-day for a person in their real life, like what would affect them. So we have addressed the following: that is the current temperature, the precipitation, UV index, cloud cover in real time and near real time. So we were able to have the live and historical data for the near and near real time. Then the temperature predictions are based on historical data using the machine learning regression analysis. Then factors in the UV index and how the public can avoid radiation injuries, factors in precipitation and what inputs are valid or invalid correlated factors with precipitation. So now my teammate Isaac will walk you through the data pipeline.
Thanks, Annie. All right, so our data pipeline uses a number of GCP technologies. We start with a cloud scheduler, which will trigger a cloud function, which will publish messages into PubSub, which data flow is going to pull into BigQuery, at which time we can do our analysis with machine learning and other live data queries that are presented in Data Studio. And I would like to show that to you now. So our cloud function is called Weather API. It uses some custom Node.js code that we wrote to pull data directly from the weatherapi.com data source. And it simply publishes that to PubSub. This function is triggered by a cloud scheduler job, which runs every hour on the hour, and triggers that for 9 zip codes that are provided in the body of that scheduler job. PubSub receives all of our messages, and you can see our traffic over the past 7 days and longer. And this is presented in our PowerPoint, but here's some initial testing, and here's our data coming in on a regular basis after we got everything set up. Data flow then pulls all the records in by having a subscription to the topic that in the PubSub topic. And so it simply pulls each of those messages in and sends them over to BigQuery using a constantly running streaming job. In BigQuery, our data is simply saved in the weather table in our final data set. And here's a preview of what that data looks like. So it provides a number of different metrics, including pressure, temperature, weather condition, precipitation, etc., as well as the location of the city that the weather data was taken from. And you can see the schema here on the left as well. And that's an overview of our pipeline. And I'd like to now take you to our dashboard, and our teammate Jan will tell us about that.
Hi, team. So I'm going to introduce our team dashboard. Let's go. So in the weather dashboard, it gives you the data of all the locations and temperature and our precipitation, UV index, and cloud percentage. And the next dashboard will be the temperature prediction. In this one, on the left side graph, you can predict the later temperature based on the early temperature. On the right side is the module we use to show the relationship between the predicted high temperature using our module and the actual high temperature of the day. Now, Darren going to show you the next dashboard for risk.
Yep, thank you, Jan. So here what we're looking at is our UV index. So figure B is our historical UV indices throughout our 9 cities. We broke out the times of day in intervals of 4 hours, ranging from midnight hour to the evening hour. We wanted to see which times of day produced the highest and lowest UV factors to give to the public. From the historical data, predicted data, we see that cities such as San Antonio, Bismarck, Phoenix had a high risk UV indexes around dusk till evening, and then the lower risk UV readings were cities such as Freeport from 8 a.m. to 12 p.m. So those times of days were deemed having the least UV indexes. Next, we're going to look at our precipitation data, and that will be our teammate Angie.
Thank you, Darian. Okay, predicting whether it's going to rain or not, of course, has a lot of value. And it's important that we stay away from descriptive terms such as heavy rain, light rain, things like that. It's much better if we can get into some quantitative data. We looked at, our data was coming, every hour, but not every weather station was every hour. So what we did is a logistical model to essentially see if it would rain or not, a yes or no, and based on the data that we had, and then use that to predict that yes or no question. I think like a lot of things, weather, we could have benefited from more data, but in the end, weather is very, very complicated and difficult to predict accurately. And that's why some of the computer models, which ours did not even come close to, are very, very sophisticated and run using a lot of variables.
That's our work. I hope you like it. Thanks.